Number one on the study guide. 9th and 10th grade students were surveyed about a new song. They could rate the song from 1 to 10, with 10 being the best. Their ratings are shown in the table. The students' ratings are then placed in two categories: worth listening to for ratings 6 through 10, and not worth listening to for ratings of 1 through 5. We're going to fill in this 2A table to summarize the data after it's been placed in these two categories. So I'll scroll back up to the data. Let me just kind of jot this down so I don't have to keep scrolling up and down. Sometimes for these two-way tables, they don't include total rows or total columns, so you have to add them in yourself because it might be helpful for answering other parts of the question. But this one, it's already there. So you also have to make sure you understand that the worth listening to would be 6 through 10, and the not worth listening to would be 1 through 5. So now let's go back to the data. So of the 9th graders, we're going to count how many chose a rating of 6 through 10. So I'm going to count. You guys can count too, and we can see if we get the same answer, but I counted 4. Did anyone get a number other than 4? Okay, so I looked at all the 9th graders. Any numbers 6 through 10, I kept track of that. Now we're going to count that said ratings of 1 through 5, and that would go in the not worth it for the 9th graders. So I counted 10. Did anyone get a number other than 10? So then add those together. That'll give me the total for this column. 4 plus 10 is 14. So that should go there then. And now we're doing the same for the 10th graders. So worth it would be 6 through 10. So count how many values said that. I counted 5. Correct me if I'm wrong. And then for not worth it, 1 through 5, I counted 5 as well. So then add those together, I get 10. And then to fill in these row totals, now you're adding these together. The total people that said it was worth it, so 4 plus 5 is 9. The total that said it was not worth it, 10 plus 5 is 15. And then this should be like your total people surveyed. It could be from adding this row together or this column, but it should be the same number. And if it's not, then you did something wrong. But 14 plus 10 is 24. 9 plus 15 is 24. So let me just put that in, make sure my answer key is right. But that's pretty much it. You read the description, you get the required information. There's usually blanks, and then you have to critically figure out, use your critical thinking skills, how to fill in the rest. But you know that they should add to the column total and add to the row total. And it's right on the key. So that's how it should be. Questions on this one? All right, questions on others from any of the 3 study guides? Okay. Not the optional one, right? Okay. All right, so number 7. All right, the one that says review the 2A table. Okay, so number 7 on the mandatory study guide. So review the 2A frequency table. Among those that like snowboards, what is the probability that the respondent also doesn't like skateboards? So for problems like these, I think you just need to read them really carefully. I could throw a lot of vocabulary at you and stuff, but you just need to read it carefully. So when it says among those that like snowboards, saying among those, that's saying out of those people that like snowboards, how many people would that be? How many people like snowboard? 27. So out of the people that like snowboards, here's like snowboards, that's 27. And when we say like among those people, out of those people, that should be my denominator. Because now we're going to figure out of those 27 people, what's the probability that the respondent also does not like skateboard. So out of this criteria, how many do not like skateboards? So that's going to be my numerator. And then I put that in my calculator. What does the fraction bar tell you to do? What math? So 12 divided by 27. Let me put that in my calculator. So we don't do long division anymore. It's 0.44. And notice my answers are not decimals. So I told you before, well, it also didn't say relative frequency, but that is what this is. Relative frequencies can be percents or decimals. So how can I convert this decimal to a percent? Okay, good. I like the times by 100% better because then you don't have to memorize what way to move it. But yeah, 44%, that matches this one. Let me make sure the key matches. And it does. All right, does that make sense? So anything that follows, given that, among those, out of these, that should be your denominator. And you should never have a decimal or a percent. Well, you should never have a decimal bigger than 1. And you should never have a percentage over 100%. Okay? Questions on this one? Questions on others? Haley? 8 on this one. 9, 3. Okay. Pedro is looking to book a kayak and review the rates for 4 different kayak rental companies. Company A charges a $20 flat fee in addition to $5 per hour. Company B is represented by this graph. Company C is represented by this table, and Company D's charge is represented by this equation, where C is the total cost and H of the hours rented. You need to rank each company in order from least to greatest based on their rate of change. What's another word for rate of change? Slope. So slope, rate of change, they mean the same thing. So basically you need to find the slope of each, and they're all represented differently, and then compare them, and you want them to go from least to greatest. So company A gives you 2 values. Which value would be your slope, your rate of change? The $20 flat fee or the $5 per hour? Okay, good. So for A, and I'll just make some notes over here. The slope is 5. All right, not the $20 flat fee because that's a one-time fee. Like if I were to put this for company A in slope intercept form, it'll look something like this. It's 5 per hour plus that $20 fee. That's like your constant. It's only one time. But the 5 per hour, you have to times by however many hours. So for A, my slope rate of change is 5. For B, we have a graph. There's lots of ways you could find slope. When it's a graph, what's like the best way probably? How do I find the slope of a graph? Okay. Rise over run, probably be your best bet. So find 2 areas that the line goes on the graph like really nicely where you don't have to estimate it. So I would pick here and like maybe over here. I know you can't really draw a triangle on your screen, but this could help you. But also keep in mind, like, look at these tick marks. They're not necessarily counting by 1. So what is it counting by? What's it counting by? Here it's counting by 10s each individual tick mark. Okay, so when I'm counting like my rise, it's going 10, 20, 30, 40, 50. Let me make sure I did that right. 10, 20, 30, 40, 50, because each individual tick mark is 10. And then for my run, see how they're counting for the run for the X. How are they counting down here? By ones. So then that's easy. 1, 2. And since it's rise over run, 50 over 2, what's my rate of change? 25. So company B is charging 25 per hour. Let me make that note up here. I'm probably gonna have to erase. For B, the slope is 25. Now, questions so far? All right, now when it's from a table, I mean, I suppose you could graph this in Desmos and then find the slope just like how we did right now, but I don't recommend that. When it's from a table, know that these are all coordinates. So like, here's a coordinate and here's a coordinate. When you have coordinates, I think it's better to use this formula for slope. Y2 minus Y1 over X2 minus X1. So pick one of these to be X1, Y1. The other one to be X2, Y2. And then plug it into the formula. Again, this is another way to find slope. I think this is better when it's from the table. So the way that I labeled it, what's my Y2? 72 is my Y2 minus Y1, which is what? Over X2, which is 4, minus X1, which is 2. So then I need to do 72 minus 36 on top. That's 36. What's 4 minus 2? 2. And what's 36 divided by 2? 18. So that's my rate of change for company C. Questions on that? This formula, I mean, you might get by this test without necessarily knowing it, maybe, but you need to know it for like at least the rest of high school. And then if you go to college, you need to know it for college. It's your rate of change formula. So there you go. And then company D, that one gave you an equation. C equals 12H plus 10. Which one is my slope? The 12 or the 10? Good. So slope is usually in front of the X or in front of the variable. Definitely not the constant. The constant's your y-intercept. So let's see. Yeah. Now we're ranking them from least to greatest. So which one should go first? A. And then and that's what you'll do on your test. You'll find the slopes of them all and rank them however way they say. They might say greatest to least. This one said least to greatest. Good on that one? Okay, Keegan, you had a question? On this study guide? Okay. So number 4, if you guys care to follow along. I will record all my classes, and so far no one's asked questions on the constructed response practice test that usually you guys do at some point, like throughout the whole day, and then I always post that key too. So please check your answers to the practice constructed response prior to tomorrow, that way you're ready. But here's number 4 on the normal study guide. Jen periodically kept track of the cost of a product to the sales in millions over an 8-month period. Which equation is the best model for sales S as a function of cost in dollars B? So there's a few ways you could go about this. These dots on the scatter plot are not very hard to see. In fact, they all go through the graph nicely. You could put these dots in as a table in Desmos, get the absolute best line of fit, and see which answer is closest. Now, on your test, the scatter plot might not be as nice. It might be harder to estimate every single point. So I'll show you how to do it by hand, which will also help you with your constructed response test. So if you want to draw a best line of fit, where should you draw it in relation to the rest of the data? Through, like I should connect all the dots? No. Okay, through the middle of the data. Does it have to touch all the data? No. Okay, so pretend that this is a really straight line. If I were you, because I do give you paper copies of the test, when you take it, I would take like one of the papers and line it up really nice to where it looks like the middle of the data. And then I draw a really straight line. And then from the line, you're gonna pick two areas that go through the graph really nicely. Of course, my line isn't that straight, so. Yeah, but what area would you guys pick? Maybe even let me use a touch screen so I can draw a straighter line. Okay, so that looks like it's going through the middle of my data where the points seem to be clustered around it. What coordinates on the line would you pick for estimating? Which one? Okay, I agree, 8-2. It also happens to be a data point, but it doesn't have to be. But yeah, that goes really nicely through the line. What other area does it look like it goes through really nicely? Okay, it's like a little under. Is there a better area?
5.5.
Okay, I agree, right here, you guys see that? That's where the line cuts through really nicely. It's not a data point, but it doesn't have to be because we're estimating what the line is. Does that make sense? So you just pick 2 points and then make one of them. Ooh, I need you on touch me. Make one of them x1, y1. And the other one x2, y2. And plug it into that formula I told you. Can you guys tell me what that formula was? Okay, good. So an easy way, I think, it's still rise over run, like it's still your y's over your x's, and then you're just subtracting the difference. But anyway, the way that I labeled it, it would be 2 minus 5 on top, and then 8 minus 5.5 on the bottom. What's 2 minus 5? -3. What's 8 minus 5.5? 2.5. Divide that out. It's allowed to be a decimal. Your answers are decimals, so that'll make it easier to see. Is -1.2 is what we're estimating the slope to be. So the slopes that are close to that will be my better options, but also y-intercept you have to take into account too. So I can't see clearly my y-intercept. I can probably estimate it. And if you look at our answers for the y-intercepts, A has it at about 10. B has it at about 6. What's the y-intercept for C? I know it's hard to see. I can't scroll. Sorry. For C? My y-intercept. 0. Good. And then I can't see D. Can someone tell me what the y-intercept is for D? Okay. And what's also the slope for D? -3. So then you want to have the equation that is closest to what your estimate is. So I'm estimating my slope to be around negative 1.2. And my y-intercept, what would you estimate the y-intercept about? 9-ish. Okay, so my y-intercept, my b is about 9. Which of these 4 answers do you think is the best? Okay, I agree. Not B, because 6 is clearly not the y-intercept. Not C, because it's also not a y-intercept of 0. And D has a y-intercept that's really close to A, but the slope is farther than A is. Does that make sense? So you're picking the one that's closest. And then when you do your constructed response, when I grade it, answers will vary depending on what points you pick. So I'm grading you based on, are you close to the real answer? If you're far off, then you lose points. Questions on that? Okay. Any other questions from any of the 3 study guides? Okay, number 1, constructed response. One second. A company that makes toys has many different varieties that people can order. The company keeps track, blah, blah, blah. Let's kind of skim this. They create a scatter plot using the data with the number of toys along the x-axis and the average price per toy in dollars along the y. First, you need to draw a line of best fit on the provided scatter plot. What's the criteria for where your line of best fit should be? Through the middle of your data where the points appear to be clustered around it. So I'd probably draw it something like this. If it's above all your data or below all your data, that's minus points. But for just drawing a line of fit in the middle, where the points seem to be clustered around it, you'll get at least 5 points. I can't remember what the breakdown was, but you'll get at least that. Question? Okay, then you're asked to write an equation in slope-intercept form to represent the line of best fit. So that's really similar to the problem we just saw on the study guide. Once you draw your line, pick 2 points from the line itself that you don't have to estimate really. So I would pick, let's see, based on the line that I drew this one, it looks like it goes through nicely at 1040. And then, let's see, maybe that one is a little high. This one looks better at 2010. So questions on that first step? So once you identify 2 areas on the line itself, they do not have to be data points. You now put it into your formula. So you estimate the slope like this. So pick one of these to be x1, y1, the other to be x2, y2. The way that I just labeled it, it's 10 minus 40 over 20 minus 10. What's 10 minus 40? 30. What's 20 minus 10? 10. What's my slope? What's negative 30 divided by 10? Okay, good. Now that's just a part of it. We want it in slope-intercept form. So we have the m of it. To get the y-intercept, I mean, I can't see it clearly on here. So in this one, I would have to, and by the way, you're free to go when the bell leaves, but if you want to stick around for the rest of this, please do. But the way you get the y-intercept is you have to plug into y equals mx plus b. So pick one of these as your xy. So 40 minus your slope that you said was -3, x 10 plus b. And then you're solving for t. -3 times 10 is -30. How do you get the b by itself? That wouldn't make the -30 0. How do I make the -30 0? Not divide. Add 30, whatever you do on one side. So it looks like my y-intercept is about 70. 40 plus 30 is 70. Hopefully that makes sense. Feel free to email me.